Now, I want to review two basic skills, okay? And it's what you see on the bottom, okay? Now, on the bottom left, this is called simplifying a radical, okay? So this is my way using a ladder and taking out pairs, okay? But many of you guys, if you can do this in your not do it in your head, but if you can, your way that you know is that, okay, is that you do square root of 1400. What's a perfect square? What's a number that's a perfect square that's embedded within 1400? It's 100. Okay, some people do it like this. So square root of 100 times square root of 14. Okay, and that equals to square root of 100 is 10 root 14. Okay, which is fine and dandy. That works out well for that problem. Okay, what if you have a problem, however, that looks like that's not as nice looking, like 96. Okay, that doesn't look as nice. Okay, but if you were to do it, some people might have good mental math and they'll play around with perfect squares. You play around with your calculator. A perfect square of 96 is 16 times the square root of 6. So 16 times 6 gives you 96, and you get 4 root 6. Okay, I'm cool with you doing it that way or whatever way you want. Okay, let me show you my way real quick. Okay, here's my way for the 1400. I'm going to break down 1400 using this method called the ladders, basically like a factor tree. It's a vertical version of a factor tree. The factor tree, the tree grows horizontally and vertically, so it gets a little gnarly. Okay, it grows downwards vertically and horizontally. This only pretty much just goes down vertically. So we just think of prime numbers that multiply to 1400. 2 times 5 times 7 times 2 times 5 times 2. It doesn't have to be in this order. This can be in any order you want. But these are basically the prime numbers that multiply to 1400. And so I wrote those out horizontally now. And now I take out pairs. 2, okay, 2 times 2 right here. 2 times 2 is square root of 4. Square root of 4 becomes the 2 on the outside. Okay, so these 2's become square root of 4, which disappears on the inside and becomes a big fat 2 on the outside. Same thing with the 5's. The 5's, okay, 5 times 5 is root 25, and that becomes a big fat 5 on the outside, which makes these double 5's disappear on the inside. And what you're left with is 7 and 2, which become 14, and 5 and 2 on the outside, which you multiply to become 10. Okay, so that's why I said you're just looking for pairs on the inside. Okay, a pair of 2's on the inside becomes a single 2 on the outside. Okay, a pair of 5's on the inside becomes a single 5 on the outside, because the logic is that a pair of 5's becomes root 25, which becomes a 5 on the outside. That's my way. Okay, I went through my way really fast and didn't hold your hand through this because this is honest pre-calc. Okay, if you need me to slow down later on, just let me know. Okay, I want to get to this quadratic formula example over here. Okay, so your quadratic formula, I'll type it up in a little bit, but for now I'll write it out. Okay, it's going to be negative b plus or minus the square root of, I like to put all the letters in parentheses, a, c, all over 2a. Okay, that's a parentheses around the b right there. Okay, and a negative sign right there. Okay, and just literally put the numbers inside the parentheses. Okay, all right, so the original equation of this basically looked like this. Okay, it looked like this. And we throw in some highlights over here. Negative b, I'll do it in blue. Boom, boom. Let me get this out the way here. Okay. Boom. A is right here. Boom, 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 and C is right over here in pink. Boom. Okay? So when you combine like terms of everything in the square root over here, okay, I'll even throw in the highlights here just to be crystal freaking clear over here. Boom. Dude, what's up with my, there you go. Boom, boom, orange, boom, boom, pink. Okay? So that's how it lines up in the formula. Okay, and pink. Okay, now when you combine like terms over here, this becomes 36. Combine like terms in the square root, I mean. Okay, this becomes 36. This becomes 36. And because you have a double negative right here and here, this becomes a plus sign. And then 36, this is 4 times 9 times 11, which is, I don't even know what the heck that is off the top of my head. That is 36 times 11, okay, which gives you 396. And then 36 plus 396 gives you the 432, okay? Now, and by the way, a double negative here becomes a positive. Now, when you break down 432, when you simplify this radical through either one of these methods or whatever method you personally do, you get 12 times root 3. Okay, so 432, if you were to do it, here's an alternate method to my method on the bottom left. 432, you can rewrite it as a perfect square of 144 times root 3, and that equals to 12 times root 3. Okay, the problem with doing it this way is that some people don't know that there's a 144 embedded within a 432. That's why I like my way here. My way over here is a little bit longer, but it's tried and true. It will always work. There's no guesswork on what is a perfect square. But like I said, whatever way works for you. Okay, now, so basically 432 simplifies to 12 root 3 as a radical, and then we're 99% done with the quadratic formula. Okay, now we have to simplify. The 6, the 12, and the 18, what's the GCF? Okay, I do 6. 6 is the GCF. Okay, so I divide all these yellow highlights by 6, and I happen to get something very convenient. It's 1, 2, 3. Okay, so 6 divided by 6 is 1, 12 divided by 6 is 2, 18 divided by 6 is 3. Okay, and so your answer is a plus and a minus version of this, which gives you these two decimals. Okay, last thing, last modification. Let's pretend this said negative 432. That means that this is going to equal to root 432, okay, that's a 4, not a 9, times root negative 1, okay? And remember, root negative 1 is basically going to equal to I, okay? So you're just going to basically slap on an I to everything that we're doing over here, okay? I, and I, and because I is imaginary, you're going to get no real solutions there. Okay, you can technically put an I after these decimals, but that's not really conventional math practice. Okay, so okay, how does that apply? Okay, so how does that apply to the big picture of what we're doing over here? So let's look at this top problem over here. Let's say you do synthetic division with, I'm going to tell you negative 3 works. Okay, and I'm going to start off exactly the same way. I'm going to get negative 18, negative 24, 46, and 44. Okay, bring the negative 18 down. I get 54. I hope I'm able to do mental math with this one. Negative 90, and I get 44. Negative, that didn't work out like I wanted to. Maybe it truly was negative 2. I thought it was negative 3. Okay, so all right, well, doesn't matter actually, because it's always good to try out the different numbers anyways. So maybe that it worked out. Okay, so let's go ahead and let me try negative 2. I think it is negative 2. Okay, negative 2. I get negative 18. Okay, negative 24, 46, 44. Please work. Please work. I don't want to have to recalculate things. 12. I'm having faith here. This is promising. Negative 22. Nope, 22. Yes. Whew. Okay, wipe some sweat off my forehead here. Now, technically, I was supposed to do some placeholders. 3, 2, 1, 0. Okay, which makes it 0, 0, 0. 3, 2. It was 2, 1, 0. Okay, but that would just make it 0, 0, 0. Okay, it doesn't really matter. Okay, the placeholders in this particular case is a little bit extraneous. Okay. Okay, let me see if I can move this over here or delete it. Okay, so really we're going to get, okay, x plus 2, and then negative 18. Remember, our exponent here is going to be 1 less. Okay, it's going to be, if this is 6, that's 5 plus 12 minus 22. There's an x right there. Okay, I'm going to GCF out. Ooh. If this is negative right here, okay, so first of all, I want you to pay attention to the relationship of this 6 and that 5. Also, if this is negative, your GCF should be a negative also. So I'm going to GCF out a negative 2 x to the power of 3. And I messed up over here. There should be a 4 and a 3 over here. Okay, so it should be, exponent should be 5, 4, and 3. All right. And I'm going to get basically 9x squared minus 6x minus 11. Okay. And this should be plus. Oh man, I am slipping today. Okay, this should be plus. Okay, thank you. So basically, everything that I've shown you so far is the same thing that we've been always doing. Okay, and remember, your GCF should be negative also. Now, okay, this is the quote-unquote new part. Okay, which is not really new actually. Okay, so you're gonna try, for this guy right here, you're gonna try perfect squares. You're gonna try x with 3r's. None of it's gonna work. So when all else fails, you just use the quadratic formula, which we already did over here. Okay, which we already did over here. All right. So I'm just introducing to you a scenario where after you do the GCF, the perfect squares or x with 3r's do not work. So you have to resort to the quadratic formula. Okay. So your answer in this case, your x-intercepts in this case, is going to be x equals 2, negative 2, 0, and for this quadratic formula, you get 1 plus 2 root 3 over 3, and you get 1 minus 2 root 3, okay, over 3. And I got that from these green highlights over here. Okay, I got that from those green highlights on the right side. Now, when it comes to writing out your answers, I don't want you to write the decimal point here. Okay, these the reason I wrote these decimals, okay, is because I want you to get a numerical sense of what this radical form means. Okay. Okay, no one really says, hey, you know what, Devin, I have 1 plus 2 root 3 over $3. Who the heck talks like that? You'll say, hey, I got pretty much $1.49. So this is more real world, but this is a little bit more mathematical. Okay, but in the end, we want our answer to be mathematical. Okay, and if there's remember, if this was a negative 432, okay, then your answer, okay, your final answer would have some i's, which means this has some i's also. Okay, so you'd have an I right here, okay, an I on the numerator and an I on the numerator here also. Okay, so again, to recap, I'm pretty much teaching you the same exact thing we did yesterday, except over here you hit a dead end because you cannot use x with 3, or you cannot use perfect squares or x with 3r's. In that case, you use quadratic formula, and boom, you just follow these steps right here. Okay, so I'm going to give you a couple problems using quadratic formula, maybe with some i's, and then we should be able to wrap it up. Okay.